Here we're going to look at question 11 from section 2 of the BMAT 2018 paper. So in this question, we're told that a moving vehicle has velocity, has a speed, has momentum, and a kinetic energy. So what we're asked is, which of these will always change if the vehicle changes direction? So if you'd like to have a go at this question yourself, then please pause the video now. Otherwise, let's have a go at it together. Okay, so the first thing to notice with this question is that it says always change. It's not just sometimes changes, and they must always change. So if there's ever a case where one of these variables doesn't change, then it's not going to fit the conditions of this question. So to try and think about which of these variables will, let's consider a particle which is actually going to be moving. So let's just imagine we've got a ball or a vehicle which is just going to be travelling along at 10 meters per second, and then it's just going to change direction and travel back in the other direction at 10 meters per second. So while I've done the velocities being the same here, they wouldn't have to be. You could have it going 10 meters per second one way and then suddenly changes to 2 meters per second the other way. Anything would be fine, but let's just use this as an example. Now, with that in mind, let's go ahead and consider the velocity of our vehicle. So what actually is velocity? And especially, what is the difference between velocity and speed? Well, velocity has direction to it. So we have like a positive for one direction and negative for the other direction. So if we have a vehicle travelling along at like 10 meters per second, and it suddenly changes to go in the opposite direction, then the velocity is going to be negative. It would be, in this case, negative of 10 meters per second or minus 10 meters per second. So this negative is a big thing because whenever the vehicle is going to change direction, the velocity is going to be an opposite sign. So it's going to have to change. There's no case where it could change direction and have the same velocity. So it will always change and therefore be one of the correct answers here. So what about speed then? Well, speed, we can imagine that if something's going at 10 meters per second in one direction and it suddenly changes and starts going 10 meters per second in the other direction, then the speed before is just going to be 10 meters per second. And since we don't have this negative thing, which velocity does, speed is just always a magnitude, then it's going to be travelling at 10 meters per second in the other direction. So the speeds are going to be the same in this case. So they're not always going to change. They could change if we were going 10 meters per second and then 2 meters per second, and obviously the speeds have changed. But in this case, they could be the same, and so don't fit this always condition. So yeah, if the speeds are the same magnitude, then there will be no change, and therefore this question is going to be wrong. Or this statement, sorry, or like variable, I suppose. And now we can go ahead and look at momentum. So what actually is momentum? Well, we can remember this equation, that P equals mv, mass times by velocity. So we've already said that velocity is going to be negative. So momentum is basically just some constant multiplied by velocity. And then this constant isn't always, won't actually change anything to do with the negative at all, because mass is always going to be positive. So just as before with velocity, when we have something moving in one direction and it changes direction, the momentum is going to become negative. And so for exactly the same reason as we had with the velocity always changing, the momentum is going to always change, because it's in one direction will be positive and the other direction will always be negative, so it can never actually be the same. Finally then, we can look at kinetic energy. So what actually is kinetic energy? Well, we have this equation that we have the kinetic energy is equal to a half times the mass multiplied by the velocity squared. But also obviously the movement is dependent on this velocity squared. But if we have a velocity squared, even if it's going to be negative, it's not actually going to be a problem at all, because squaring it is going to get rid of this negative sign. So v squared will always be positive. And therefore, our kinetic energy, half mv squared, is always going to be a positive value. So if we did have a case such as this, where it was going at 10 meters per second in one direction and then 10 meters per second in the other direction, then the kinetic energy, it wouldn't matter which direction you're travelling in at all. It would be the same in both. So if you have the velocity being the same in both directions, then it will be exactly the same value, and therefore will not. While it could change if you have different velocities, it's not always going to change. So this one is going to be wrong. So if our velocity and momentum are the ones which always change, then this is going to correspond with answer E given in our question.